So thank you so much, Praveen, for that very generous introduction, and a very good morning to all of you. Thank you. And it's a pleasure to see all of you here this morning. When we entered the room, I think it was just us, the panelists. So now it's good that the room is full because we have such an erudite panel. It would be a shame if we didn't have the quality audience who could take a lot of takeaways from them. Now, I'm sure all of you would agree, and at least I experience that in any meeting that I go for. I think it would be an absolute exception if I didn't hear some of these keywords: electronic manufacturing, then EVs, AI, data centers. Would you agree? Yeah? There's never a meeting where you won't hear these words. And the fun part is, while Praveen mentioned that these are all our sunrise sectors, right? The country is looking at becoming the electronic manufacturing hub for the world. We are constantly looking at EVs to optimize our fuel consumption as well as be sustainable in our, in the transportation and so on. Equally, data is now the new oil, and data centers is taking center stage to that extent, along with artificial intelligence. And we had a good debate yesterday on AI as well in the room. So the interesting part is that this panel actually very well connects to this conference's theme when we're talking about the next gen chemicals. Okay, because these are the very next gen chemicals that are going to form part of all these sunrise sectors. So you're here in the room for all the right reasons. Let me start this discussion with Dr. Yogen. Dr. Yogen, please could you share your perspectives on how important is material science know-how and capabilities for the ecosystem development of critical components of electronic manufacturing systems and services?
Thank you very much, Aashish. It's always wonderful to work, and you are so detailed and well prepared for all events. So I will try to give justice to the questions, which is also not so easy to answer, but I will try. Okay, so good morning to all of you. I think we all had a very good start. Yesterday also it was very enriching experience, and I thought of only attending few sessions yesterday, but I ended up attending most of the important sessions which I thought I should be. So your question is that for advancing India, right? So this is advanced material is there, and why material science knowledge or material science is very, very important. So I give my own examples in terms of my career. So I studied industrial chemistry mainly, right? So in my master's and undergraduate and then PhD also. So in applied chemistry, industrial chemistry, at the master's level actually, postgraduate level, you are actually having one subject called material science. Material science is is a subject which is having two interfaces, right? So it is of course physics part of the material and also chemistry of the material and technology. At the same time, how to make use of this material and to put it in a different physical form. Just for example, you have your laptop, right? So, and it is having aluminum magnesium alloy as a housing material. Now it is replaced by polycarbonate and polycarbonate ABS blends, and also having a carbon fiber or glass fiber. So if you really want to understand industrial designer of HP or Apple, in their R&D, they have material scientists, okay, who are working closely with the designers of the devices. So translating designers' fantasies or a designer's concepts to the product, the industrial designers in concepts, he has to put it on paper, drawing board, right? So this is how the device should look like. And then obviously the R&D scientist, or polymer scientist, material scientist has to translate into the properties, that what properties it should have during the processing, but before that also to fulfill the end use performance. So material science, if you do not know the morphology of the polymers or the materials which you are talking about, how aluminum will behave, how aluminum magnesium will behave when you do the formation with the CNC machine, for example. So, or stamping and cutting and clamping and all. So, you need to know. And therefore, if India has to really get into this advanced manufacturing of these sunrise sector devices, whether it is a 5G, 6G, or even for robotics and drones and all, of course, you need a very good chemist. You need a very good engineers. Definitely, you need a physicist and the optics engineers and. But at the same time, you need to have in your R&D material scientist, because that's the language your customer will be speaking. The OEMs of the world, the Apple and Samsung and network devices, Nokia's and Ericsson's of the world, and their designers will talk the language, and you actually as in an ecosystem as a material supplier, right? Whether you are supplying metal or you are supplying electronics component or you are supplying, because at the end of a day, you have this particular final device has got all streams of the science and engineering is playing. So it is like in a musical orchestra. So the music can only come out when all players, in some cases, you must have seen this opera and all these things, where hundreds and sometimes thousands of musicians playing different instrument to get that particular melody or particular song. This is exactly same. When you are trying to do localization here in India, as very nicely my colleague Suresh yesterday gave me one more word, we talk about China plus, and he yesterday gave a very good concept calling that Europe plus. So if you want to do something in India, which Europe has been doing for last 4-5 decades and China's doing in last 2-3 decades, you need to do that, and you need to develop that capability in terms of skill, manpower, the scientists, the engineers, and of course, this advanced manufacturing technology. So it is not only hardware, also software and intellectual capability. So therefore, material science is important. So let me give one example.
Sure.
I already gave the laptop example. So say, for example, now 5G, 6G, and maybe in future it will be 7G and 8G. Today morning, I was sharing one anecdote, which I mean, I keep learning every day, and that's something the fun of being in science. So yesterday we are implementing one very good software called MES. We are trying in our manufacturing. So the developer, I had an interaction yesterday. He said, Yogendra, do you know how often the data from your plant, we get it refreshed? So I just scratching my head and said that maybe few minutes. He said that every 3 seconds, whatever is happening in your production line, in your reactor, that data of temperature, pressure is getting transferred, and we can see. So I thought it's a real-time data, but real-time data, to have that, it should be done in 3 seconds. Now think about it, that you are having a housing material for those servers, okay? So that server and the housing material should be able to enable that, transferring the data from your PLC to SCADA to server, and server to the analytics, the software, and then software actually telling you what to do, right, to the instrument. It's not only the control on your equipment, your production line, but actually the server is guiding the MES. So that to enable that, the housing material of the server has to enable that. It should not interfere the signals, obviously, otherwise the whole concept will not work. So this is an example of how material science, the knowledge of the material science is very, very important. And I give one more example. So laser marking pigments, you must have heard about it, right? So laser, how it works, I don't need to start a class on how it works. And my fellow colleague from Clariant, he knows a lot. So it absorbs particular wavelength of a light, right, or a laser, and then it reacts to that, and this is how you mark the device with the laser marking. Similarly, your autonomous car has to collision ADAS and all, the material has to be transparent to that signal, radar signal, otherwise that will not work. So therefore, you need to design with a proper understanding about the part thickness and how it is going to be achieved, part thickness. So you need to know the morphology and processing conditions, and then only the selection of the right polymers or the metals, so that to make it happen for that device sensor. So this is an example I thought may be useful to elaborate. Yeah.
Thanks so much, Dr. Yogen. I think that was really a great start to this panel discussion because often people just think it's all IT, right? Everything digital is IT and data centers and everything is, more savvy towards that industry. I think we really need to do something from a chemical branding perspective for people to realize that it's all chemistry at the back end and we are the guys who are architecting a lot of that. Let me move on now to you, Nitin, to more around lithium supply chains. Let's move to that area. Lithium supply chains are being highly concentrated globally. How can Indian chemical industry accelerate commercialization of alternate chemistry like sodium ion or zinc air batteries?
Thank you, Aashish, and good morning, everyone. So I wanted to thank Dr. Chauhan for really setting up the agenda pretty nicely for us. And thank you, Aashish. I think you rightly pointed out that rather than competing on the lithium mining, actually, India should aim to take the lead in the chemistry behind advanced battery materials or advanced batteries for that matter. And this nicely plays into the strengths of the Indian chemical industry with focus on process innovation, specialty chemicals, advanced trees, and the sustainable manufacturing. For me, silicon ions, what you were mentioning, or SIBs present a immediate opportunity due to the abundance of sodium in India, as well as the high thermal stability and the suitability of sodium ion for stationary energy storage and affordable mobility. Now, this presents a very good opportunity for the chemical companies actually to quickly commercialize this technology. And the levers for quick commercialization, actually, I'll say there are three focus areas. First one is the advanced battery materials. Second would be the process innovation. And thirdly, it would be the design by circularity, actually, the circular design. So I'll just give details on each of them. So when I mention about advanced battery materials, we should be able to develop and scale cathode material. I think my colleague would be able to highlight it more. And then we need to have one of the biggest bottleneck in this whole chain has been the hard carbon anodes. So this, if we are able to make from the sustainable biomass that India has, it would be a breakthrough. Then we are looking at high performance catalyst, sodium salts, binders, conductive additives. So all these, if we are able to scale up, we will be really able to accelerate. So point one. Second, I was mentioning about process innovation. I think we should be able to leverage on our expertise in catalysis, purification, formulations, and the continuous manufacturing to improve cost, scalability, I think consistency of these battery materials, which would be key. And lastly would be the circular design, which I was mentioning, where we need to build integrated ecosystem where the production, recycling, and resource recovery would be the key, because this will help us in reducing the dependence on expensive import minerals, critical minerals. Yeah. For quick commercialization, chemical companies need to partner with OEMs, they need to partner with research institutes, they need to partner with academia, they need to partner with battery startups, so that this is to establish pilot scale manufacturing, standardization of testing protocols, and build integrate battery material clusters. And the focus initially should be on, as I said, on your affordable mobility, which is two-wheelers, and stationary storage, energy storage systems. Yeah. think this really gives us an opportunity as a chemical industry to no longer just think beyond supplying chemicals, to act as an innovation partner to enable this whole value chain actually. Thank you.
You're absolutely right, Nitin, because we all know that, commodity chemicals and certain chemicals are, very low margin. If we really want to play in the higher margin games, we will need to innovate and we will need to partner with the ecosystem to develop something new, so that then the companies can see, some, high premium products also, which still will be more competitive than the imports that we have coming into the country today. So, Ankur, that brings me nicely to my next question, which I would ask you. What specific chemical engineering and processing innovations do Indian companies need to adopt to refine battery grade materials locally instead of relying on imported precursors?
No, thanks. I think it's a very interesting question because if you look at the battery ecosystem here, we have a huge demand, but we do not have materials. And second part is that we do not have advanced technology to refine those materials. The demand is picking up and the import dependency is going up. Now, that leaves us to 4 classical parameters of targeting any advancement in the battery refining technology. A, move as much as continuous compared to the batch refining process. And I'll explain what I meant by that. B, get your particle size distribution as well as your polymer metallurgy right so that the purification can be achieved. C, graphite. India is one of the large producer of graphite, but most of our graphite are linked to petroleum source. And we still do not have a very advanced technology of graphite stripping so that in maybe in 2 stages, we can get a battery grade graphite without incurring too much of a processing cost. Last one is our ability to extract refined material from a battery waste. I think a lot of startups are working on it and that is still under process. So let me just dwell deeper on each of them. What I meant from batch to continuous process is basically there is a lot of hydrometallurgy technology which is being developed in Taiwan and Japan, where using product like peroxide and high purity water, people are able to reduce the recycle time of the battery materials. Now, we are not fortunate enough to have the upstream material available where I can have huge quantity of the waste which I can use it again and again. I have to rely a lot on getting most out of the raw material which is available. So using the hydrophonic technology to get more purity and moving from batch to continuous process will give a better yield. Second thing, advanced material and particle size distribution. What a lot of companies are doing is trying to bring new polymers instead of using conventional chemicals to get the homogeneous distribution of the battery material. What it does, it provides the same property, it reduces the cycle time. At the same time, the qualification approval happens very quickly. The third one, which we talked about, the graphite stripping. Now, the one battery material which is available in India in a decent quantity is graphite. But most of our graphite is coming up with a lot of petroleum residues, which actually makes it very challenging in terms of the cost and purity. Typically in India, there are 3-stage processing happening, and it adds to close to 10% on the variable cost so far as the graphite refinery is concerned. Now, one thing which people always say, oh, we do not have technology, the Western world is not giving us how to go about it. So ICT is working on a technology of graphite refining. I think if that becomes successful, maybe we'll bring down our variable cost of refining to a significant level. The last one is how to extract material from the recycled one. Now, I understand more than 12 to 13 startups are working on it. The problem is collection and the homogeneous nature of the collected material. Even the collection is a very new phenomenon, and it's so distributed that there is a lot of logistical cost involved. Second, getting the right mix of collected material before we start extracting the usable battery material. Now that requires a technology access. Japan is doing it, Korea is doing it. but some of those technologies are not available at scale. Very few large-scale chemical companies have tried to set foot into it because startups, the ideas are good, but the amount of capital required to make it happen at a scale cannot be only done by a funded startup or an incentive alone. You need a large corporate houses to commit at a scale and make it happen. Government of India is proposing a battery recycle hub, but to be fair, that is still 3 years away. So overall, I think these 3-4 steps, if we can take it, we would be there. And then if you look at the way Japan and Korea is going, even they don't have the significant amount of battery raw material, but they are more focusing on processing innovation to get the things right.
That's great, Ankur. Very insightful comments. And while we're on the topic of purity, let me turn it over to Ambuj on semiconductors. Ambuj, semiconductor manufacturing also demands electronic grade chemicals and gases with purity levels which are extremely stringent. What are the biggest technological, quality control, and infrastructure hurdles Indian chemical manufacturers must overcome to consistently achieve these standards, and how can partnerships accelerate capability building in advanced materials and process chemicals?
Yeah, thank you, Aashish. And first of all, really glad to be part of this esteemed panel and talking on this interesting topic. So first, let me talk a couple of minutes on the semiconductor and electronics value chain from chemicals and gases lens. So the semiconductor, it starts with silicon. So silicon, we all know it's abundant element available in nature. And then it is processed, refined to make very high grade up to 9N to 12N sort of thing, depending on the technology nodes. This for refining of silicon to make polysilicon, you need various gases like HCl and silanes. You need a lot of wet chemicals as well. Then it goes to make your ingots, which is sliced to form your wafers. And now the wafers are the building blocks for any fabs, any chips. So these wafers goes to foundries. In the first part of the value chain, mainly you have two companies which is holding 40% of the value chain, that is Sinetsu and Somco. And then there are some European and US companies. In the foundries, you have like multiple steps. The first start with the patterning, which is photolithography. So in the photolithography is actually a Xerox machine in which the prints are given to a wafer. And in that case, you need photoresist or the photo-based chemicals, which is extremely high pure. You need monomers, proton acid generators, all these kind of chemicals to make photoresists. Then you have various other steps like cleaning, etching, doping, chemical mechanical planarization, and the most important is the deposition, which is your atomic layer deposition and chemical vapor deposition. And these steps repeat several times. So it goes, in some cases it also goes to more than 1,000 times. And each of the steps you have a lot of process and chemicals being used. In the cleaning side, you need various chemicals, the basic chemicals like sulfuric acid, nitric acid, ammonia, ammonium hydroxide, hydrogen peroxide. You need a lot of solvents like acetone, IPA, and so on. In the your gases side, like cleaning, etching, and deposition, you need various fluorinated gases. You need various arsine, phosphine, all the toxic and lethal gases. It's a part of the semiconductor industry. And then, once this value chain, like the chips are made, then it is going for the OSAT, ISAT sort of thing. And then it is going for the manufacturing of iPhone and all these things. So now, like it's the direct chemicals I was talking about. Apart from that, there are a lot of indirect chemicals being used. So in the processing of semiconductors, you have some of the chemical processes are really very notorious and violent that emit lot of heat. You need to maintain it at the right temperatures to work it properly. We see from outside that it is working very fine, but for that you need lot of cooling based chemicals, very very specific coolants, dielectric non-conductive chemicals. Some of the processes are working at very low temperatures beyond minus 200 degrees Celsius. That there you need liquid helium or liquefied helium to cool that part. Then this, even in the electronics value chain, You need a lot of wet chemicals or the dielectric fluid to clean your hardware for thermal management system. In the case of fabs, you need a lot of polymers, because like you have all the coatings, piping, tubing, fitting. This all needs to be made from the polymers or the fluoropolymers. Even the chemicals that are very pure, that is also like you need no contaminants in that. So that's also made out of fluoropolymers or the fluorine based or some of the plastics, so that you can purify the chemicals that's going into the fabs. So ultimately, like in the semiconductor fabrications, it's direct chemicals and indirect chemicals. And in the indirect chemicals, the purity is not that important. It's important, like you can go up to 4N grade, or you have certain metal element requirements, or certain impurities requirement. But in the direct chemicals, really very stringent. So now it's like where we want to enter, which is the low-hanging fruit for India to enter. So first, let me talk about from the direct lens, direct chemical lens. So here, purity is important, but more than that, the impurity is even more important. So in your impurity, you have metals, you have various ions, you have any oxygen-containing compounds, you have moisture, you have particle size. It also depends on where are you going to pitch it. The specification varies from fab to fab. It depends on whether are you pitching for 300 nanometer chips, or are you pitching for 2 nanometer chips that's going for AI chips. Are you pitching it for memory chips, or are you giving it for the logic fabs, or are you giving it for the your display fabs? So everywhere the specification varies. Now, coming to the technology, so like once you are going for very high purity and impurity, how will you measure it? So there you need very high-end analytical techniques. There are certain gases which are not even measured by GC, GCMS. You need advanced analytical techniques. There are metals, you need ICP-MS to measure it, but there are ICP-MS of very high caliber which is measuring your PPT levels. Like triple quad ICP-MS, you need a lot of other analytical techniques. You need clean rooms, those kind of technological capabilities. On the infrastructure side, it's very important, like you should have a clean room, you should have a good logistics system, because in the semiconductor fabs, you need lot of gases. So gases costs are only 20%. 80% cost goes for handling, packaging, transporting, logistics, and these are very lethal. So those kind of capabilities needs to be there, which actually becomes entry barrier when you go for the gases side. And then also the consumptions are also very less in the case of semiconductor for these gases. Now, partnerships plays a very critical role, in the ISM 1.0, there were 12 number of fabs being approved by the government, mainly on the fab side and the OSAT side. Now, the lot of Japanese companies or the global companies, they're eyeing towards India to have partnerships. In the semicon, if you see, last year also, I found more than 30% presence was from the Japanese company. Even your Korea, Taiwan also having a very good interest in India, and some of the chemicals, like wet chemicals like sulfuric acid, nitric acid, the consumptions are pretty good even for Tata Fab that's going to come up.
Sure.
So all are looking for collaborations and partnerships. Because the capex is also higher, and if there is some partnerships, then the risk is shared. And all the established like the customers, they are looking for established suppliers, established sourcing partners.
Yeah.
They cannot go and buy from anyone else.
Yeah. So let me then ask you, Ambuj, because you talked about the whole value chain, and you spoke about beyond silicon wafers, semiconductor fabrication relies on a vast ecosystem. You spoke about photoresists, there are etchants, there is CMP slurries, deposition chemicals, electronic gases you mentioned, specialty solvents, so on. So which of these segments represent the most attractive combination of low entry barriers, high value addition, and export potential for Indian chemical companies?
Yeah, so actually I feel, based on my discussion and being in this sector for last 3-4 years, initially we should start with a low-hanging fruit. So low-hanging fruit would be the chemicals that goes for cooling of the semiconductor machines, or your the electronic cleaning, or the precision cleaning, vapor degreasing, or the cooling side of things, because there the purity is important, purities are also important, but still, it's a journey. The second thing is, if you see the wet chemicals, so wet chemicals, there are different grades of wet chemicals. It starts with G1 grade, where you have up to 100 ppb level of metals are allowed. There are some impurities are still not that stringent. Then there is G2 grade, G3 grade, G4 grade, G5 grade. So G5 grade is mainly used in the fabs in Korea and Taiwan, which is below 10 nanometer. G4 grade is mainly used by Tata, so that would be for 55 nanometer and below. Then you have G3, which is the mix, around semiconductor and display. And then G2 is your solar companies that are using. So if you want to enter into any wet chemical side of things, so I think the start would be also pitch for the solar companies, because there is a lot of solar cell manufacturing going to happen in there. It's already started. So there is a learning curve. India has to travel that journey of learning to reach to that stage, so that they can pitch to the semiconductor industry. So first enter from the lower value chain, low hanging fruits. So that is your mainly the wet chemicals, that's for solar, and then start for Tata and these companies. There you can get easily technological support from the global partners. It's easy to scale. Also, we have a lot of value chain in India, the ecosystem is happening in India. The third area which I would like to see is, generally what we also do as a Navin Fluorine, that we sell a lot of our chemicals as a raw material to various global companies who do the purification at their end, and they supply to the fabs. For example, I will tell one example of HF, hydrogen fluoride. So hydrogen fluoride in Japan, only 2 companies are there who uses more than 50,000 tons of hydrogen fluoride. Almost all the chips that is manufactured, they pass through hydrogen fluoride. So companies can provide these chemicals as a raw material to these companies. They can do the purification, and then they can supply to the fabs. So that's the easiest start. You know the value chain, learn the value system, but it's not like you can supply the industrial grade. There also you need to do some purifications, bring some metals down, but there you can start. And the other thing is, you can slowly move to the photoresist also, but photoresist is really a very tricky play, because it needs very, very high purity. But in the photoresist is made of your proton acid generator, it is made of monomers, it's made of solvents. So proton acid generator, generally we get a lot of inquiry from Japan customers and others, and the volumes are very small. So there you don't need very high purity. So MSMEs and SME companies, they can pitch more on the photoresist proton acid generator. And once the Indian ecosystem is developed, then they can move more towards the photoresist, because it's a very high margin product. And although those companies who have entered into the photoresist, they have grown like anything. If you see last 4 years data, the major 4 companies are there in the photoresist, which is Fujifilm, JSR, TOK, and then one more, and Resonex. So these all companies have grown more than 20% for last 3 to 4 years. So that is the main product, but it is only for India. It is still time to go to that photoresist actual manufacturing. And then the last thing which I would based on my understanding, is to enter into the chemicals that goes as a precursors, like atomic layer deposition or vapor deposition, or the etching chemicals, because there the purities are very high, 5N grade, 6N grade, even goes till 8N grade, because that's going directly to the chips. And it's very complicated, you need a lot of learning curve to achieve that, but there the margins are very high. So I think in the next 7 to 8 years, once the wet chemicals, indirect chemicals, raw materials, and the photoresist evolves, then we can enter into this side of things.
Thanks, Ambuj. That was very comprehensive. Let me move on now to Ankur. Ankur, solid-state batteries are considered as the next big leap in safety and energy density. What is a realistic timeline for India to transition from liquid electrolytes to solid-state chemistry at a commercial scale?
Well, interesting. First shot on the question, minimum 10 years. The reason being, if I look at the current ecosystem of India's battery emergence, a lot of focus right now on factories and getting the lithium thing sorted out. And most of the PLIs are announced in that area itself. If you look at the typical life cycle of a solid state battery development, it is always sequential. You go with a small size of 20 mAh to 50 mAh, which is your wearable devices, your hand wrist and your trackers and sensors. Then you get into the medium size solid state battery, which is your premium four-wheelers and two-wheelers. And then you go to a mass scale production of solid state. Now, it's relevant to see who is doing it and who is doing it successfully. It's mostly the large automotive company, whether it's BYD, Toyota, Honda, or large-scale automation companies, whether it's Honeywell and Siemens. Technology is closely guarded. Now, if you look at the sequential capital allocation of Government of India, it starts from getting the first stage of a battery ecosystem sorted out, which is the lithium-driven, and then once the government realizes that there are not enough lithium available, they will go into NMCs and the sodium-ion batteries. So government is a lot glued into getting the conventional gigafactories sorted out. Now, the second question comes in, who will invest? So typically to solid state battery to come in India, you have to rely on a cluster or ancillary model led by one of the MNCs. Suppose Toyota tomorrow decides that even today Toyota is more hybrid than EV, and whatever EV they are making in Japan or the US is not moved in India. So you want one of the electrical battery late ecosystem manufacturer to come in India and set up an ancillary model. It means you are not only making the battery, you have a material guys are in surrounding, and you are bringing the technology as well. The challenge is that does it have to sequentially follow the way other economies have developed solid state batteries? May not be, that in between you can go from conventional to semi-solid to solid. There are a lot of innovation happening in a polymer gel ecosystem where they are using as part of a semi-solid battery compared to the conventional raw material. Is it feasible at scale in India? Depend upon the user industry. So if solid state has to come in next 10 years, it will depend on three factors. One, strong capital support from the government. One of the large global OEM has to come to India in an ancillary model where the material as well as the consumption has to happen locally, because the packaging cost of these materials are very high. So even if you import the semi-finished battery and start packaging here, it will not make the relevant cost structure. And until it matures, it will always compete with lithium-ion ecosystem. So people will be worried about the margins also coming out of the business. And last but not the least, the mass scale production has to be achieved, because looking at India's demand, if it has to create a parallel business for solid state while lithium and NMCs and sodium ion is picking up, the consumption has to be grown in an equal proportion. If the mass may not be achieved, people will not put up the capital as well. So the capital intensity has to meet with demand and supply ecosystem. And that is why 10 years is my best guess. If it happens earlier, would be great.
And let me stay with you and also ask you and Dr. Yogendra the same question, because you did talk about government support. So how can the Indian chemical sector better align itself with the government initiatives like the PLI schemes for advanced chemistry cells and semiconductor electronics to build a resilient, self-reliant supply chain without having to rely on a Toyota or BYD alone?
Got it. I think if you look at the whole PLI ecosystem of ISM 1.1 and now the ISM 2.0 is also being announced, one, I will not say mistake, or one deficiency in this policy was that most of our PLIs are designed to get the end product first and not the whole ecosystem. Typically, the finished product-led incentive come first, followed by intermediate, and at last you look at the raw material and the input cost. Whenever you are designing a PLI, and if you are substituting the import, you have to incentivize the intermediate and material production as well as you are doing the finished goods. Assembly is always easy, and therefore PLI into electronic manufacturing and pharmaceutical was picked up immediately. But the moment you look at the chemical PLI, why it's slow? Because A, the capital push is very high. The base is very high. So government is also conscious that how much money they have to dole it out to industry. The third is that uh, chemical is not directly the finished industry, it's a processing industry. So you have to also incentivize the PLI to the end consumer. So instead of looking just an assembly-based PLI into semicon and battery ecosystem, start distributing it to the material guys as well. And then you will see a lot of private capital start coming to this industry.
Sure. Dr. Yogendra, any thoughts?
Yeah, actually, we always talk about the intelligent Indians, the cream of the society is working outside India, right? So, bearing all of us here who are here and trying to make a difference. So, government has to, and I think there are certain news which I followed in recent past that government is incentivizing reverse brain drain. Okay, so government actually promote that thing wholeheartedly, then that will further enable developing the capabilities for the sunrise sectors and very, very advanced devices manufacturing capability. So this is exactly what, and I will come to that question maybe later with my own experience in China, but China actually done that in last 20, 25 years. The China government has sent the very bright scholars with a state-sponsored scholarships in thousands and thousands to Western world, okay, to train them, and then they have actually incentivized to come back to China to make the modern Shenzhen or the Guangzhou and all these clusters in China is not something has happened overnight by some American OEM started manufacturing in China and this has done. It is not like that. So India has to, China copy whole world, we need to copy here, China probably, in terms of how we can, government can incentivize industry sponsoring the brightest people or the talent to send to those universities and company for, we used to call it the expert assignments, right? Obviously with some sort of a bond, like doctors, they have to write a bond that they have to serve in a villages and all. That's what my cousin is saying. So we need to do that for IITians and IISCs and also the brightest of India. This is my expectation from the government as well as private sectors and public sector. You actually create a program so that you prepare yourself to play and win in a sunrise sector if we would like to participate in a great growth story of India. So that's what I would do.
Okay. We unfortunately don't have government representatives here to hear your ideas, but it should probably get conveyed to them in some shape and form.
Actually, I did that directly to the government officers during the Vibrant Gujarat event, which happened a couple of weeks ago in Gujarat. So IS officers and from the Ministry of Commerce and Niti Aayog also were there. So I grabbed that opportunity to give this gyan to them that IS are the brightest, but all other bright scientists and engineers should also remain here to help you. And you don't need, I mean, of course, Ernst and Young and McKinseys are required, but we need to have our own McKinsey and Ernst and Young and BCGs to guide you, IS officers. Not all the time you create a industry policy for electronics manufacturing services with a borrowed knowledge and gyan from these famous five. Sorry, I'm not hitting the Ernst and Young and BCG here, but why not? I mean, why we cannot create our own? We are the, all these famous CEOs of the Googles of the world and Microsoft, they are Indians. So why we need to have a external consultancy firm to advise to formulate a policy? I mean, this is my bit of a very patriotic, passionate take on these things, Aashish.
Yes, we are very much part of India. Just want to clarify that. But okay, let's get to, Nitin, with the China Plus One strategy, restructuring global supply chains. What distinct competitive advantages does India have that can help domestic companies eventually export advanced battery and semiconductor chemicals worldwide? And Nitin, you have the advantage of working in a joint venture of an MNC and an Indian promoter-led, setup. So,
Yeah.
if you could throw more light on that.
Yeah, surely. So, frankly, I see this China plus one shift as a strategic opportunity for the Indian chemical industry actually uh, to emerge as one of the strong players and suppliers for the advanced battery and semiconductor chemicals. Not only just competing on actually on cost, but also through innovation, specialty chemistry, and sustainability. Yeah, and India's, I should say, the advantages are very clear. First and foremost, we have a strong specialty chemical ecosystem. We can leverage our expertise in high purity materials, in fluorochemicals, in catalyst, battery storage and energy storage materials. Secondly, just what Dr. Chauhan was mentioning, we have cost competitive and a high quality manufacturing, which is well supported by a talent pool of skilled engineering graduates. So I completely agree with him when he says I think there should be some government policy on having some sort of a reverse drain. Thirdly, I think we have a very large demand for EVs, for semiconductors, for energy storage, which enables us actually to scale before the exports actually start. Uh, Fourth, the PLI, I think Ankur has already touched upon store with Dr. Chauhan. So I think the policy support coming in through the PLI schemes and the investments specifically in the development of this ecosystem has been very important. For me, lastly, it is the sustainability advantage. Uh, if you talk of sustainability coming in from a joint venture, you are asking, I think I can proudly say now with this joint venture between India Glycols and Clariant, we are the largest green ethoxylators of the globe. So our next competition is actually Croda, which is not even one-third our size. So sustainability is an advantage that we need to cash in on. Specifically, in the focus is coming towards low emission carbon manufacturing as well as circularity. For me, the biggest advantage India has and where it lies is in combining what Dr. Chauhan was mentioning, our expertise in material science, innovations, specialty chemistry, and manufacturing excellence. If we are able to do all this together, I think we would be a force to reckon with in the near future, maybe 10 years, like what Ankur was mentioning, or down the line in the battery chemicals and advanced material chemical space.
I think all of us are gunning for that, right? That the next decade, onwards should belong to India. But before I get to that, Dr. Yogen, you have stayed in China for 4 years plus. How do you see that?
Yeah, actually, that's a question I repeatedly get within my company also, and I'm more than happy to share the learnings which I had. It's a great opportunity I had actually when China was almost exploding in terms of manufacturing and has become a factory of the world. So I was there from 2012 to 2017 in global headquarters, working for a German company in China and taking care of the sector which was electrical, electronics and advanced drones and all these products. So this was my fortune, I would say, that I learned from that. So how they did it, okay? So uh, economy of scale is one thing. So after post-World War, there was a made in Korea or made in Japan products were also not regarded as a quality product, right? So how Japan and Korea has evolved in terms of refining their manufacturing process is going to the next level, right? Same thing China has done. In front of my eyes, actually, when Foxconn of this world, Taiwan is ODM company who supplies to Apple in South China, and when more than almost 1 million employees they employed in South China, and they when I first saw the Lenovo factory and the tier 1, tier 2 of the Foxconn molders, Foxconn is a device manufacturer, right? So before that you have a molders and all. And I saw in a short time of 4.5, 5 years, how they have converted from semi-automatic plant to fully automatic plants and manufacturing process. So right first time, that is the motto driving. So China is striving for the excellence, believe me. So earlier the product of made in China product were not considered good, right? In India also, we say though made in China not so good. Now you see the latest car of the BYD or even this Xiaomi. Xiaomi, the meaning of the Xiaomi is the little rice part. I have actually had a fortune to work with the promoter of the Xiaomi in Shanghai and Suzhou. Actually, they started from a frugal innovation, right? With the 4 or 5 very bright engineers started this company. Now Xiaomi, when they first came to develop the iPhone copy or something like that in China, and then the scooter, electric scooter, and now even car. So if you have seen some videos, and I have seen the car in March this year, Xiaomi car in Shanghai running on the road. I mean, that is mind-boggling. The interiors of the car, the textures, the finishes, the electronics embedment and all. This cannot happen overnight without really developing operational excellence, right? So this is how China has done it in terms of that. So with the current manufacturing level, what we have in terms of our efficiency, is not actually going to help us. So very rapidly we have to evolve from current state of our manufacturing practices, and this can be done by collaborating. You know that when you cannot compete, you have to collaborate, right? And this is a very good thing which China has taught to the world. When you cannot compete, you attract those companies who can teach you how to do it. So I am very hopeful that with the advancement and these localizations and PLI scheme and all these industry clusters, in Delhi NCR and Sri cities and Baroda and Sanand and all this Dholera is happening for semiconductor. And all these big companies, the foreign companies, they are the kind of the leaders, right, in innovations. They are coming here, so that's a great opportunity to learn and evolve ourselves in the next 5 to 10 years so that we also elevate ourselves in terms of advanced manufacturing capability and made in India as a kind of a quality product, kind of a reputation we gain. That is my dream in next 10 years.
Excellent. So, yeah, sure, Ankur.
Just to add, Dr. Chauhan, quickly in 30 seconds. I was in one of the trip to Europe, and one of the senior executive of a large European company gave a very nice explanation why China in chemical or material science is here and how they got there. For last 20 year or 25 year, a lot of young Chinese engineer went to Europe for study. They got employed, all the leading European chemical company, reach up to the middle management. They went back to China, funded by the government, and started their own entrepreneurial journey into chemical and material, setting up their own companies. So today, if you look at China, the threat is not from the Sinochem or Chem China. It's actually these $200 million, $300 million, now reaching $1 billion companies who were actually started by English-speaking, European-educated entrepreneur funded by the government who actually worked in Europe. Second part in China's success is the patents generated by universities. In India, I'm sorry, you are paid to teach. In China, your job's incentive as a professor, as a doctoral student is actually linked to generating the patent. You go to Shanghai University, the amount of patent they are churning out is huge. So there is a structural issue with India compared to China in terms of advancement. All of China's growth after learning from Europe is homegrown. They have refined themselves multi-notch above what they were 20 years ago.
Great insights. Thanks for sharing that. We spoke about it a little while back. Nitin, you alluded to sustainability. And we spoke about how AI is here to stay. So AI growth is driving unprecedented demand for advanced chips and hyperscale data centers. But this is also bringing significant energy and water challenges. How do you see cooling technologies evolving over the next decade, and what role can the Indian chemical companies play from advanced thermal fluids and materials to water treatment and energy storage solutions in enabling sustainable AI infrastructure? And how can we bring in sustainability from inception to develop this ecosystem?
Okay. So see, AI has actually transformed these data centers into one of the largest world's consumers of water and energy, making sustainability actually a core to design requirement rather than just an operational consideration. Yep. Over the next decade, in my opinion, I expect the cooling technologies to evolve from the conventional air cooling to direct liquid and immersion cooling, uh, significantly making them energy efficient, and also supporting the ever increasing I should say capacity of power capacity of these AI chips. Uh, this provides a good opportunity for chemical companies like ours, where we can go beyond just being suppliers, but as enablers in the whole AI infrastructure ecosystem, uh, where the chemical companies can help in developing advanced heat transfer fluids, look at high performance polymers and coatings. Uh, Another area is water treatment and water recycling solutions. And last but not the least is the energy storage and battery materials. So, and sustainability actually would be the key. And like what you rightly mentioned, Aashish, it has to be embedded at the very start, in the inception phase itself. Uh, every material, every process, uh, when you are designing, we have to use life cycle thinking, minimizing carbon emissions, minimizing water consumption, minimizing wastage, and enabling circularity. Yeah. So, and how you can do this is you need to utilize green chemistries. You need to utilize your renewable feedstocks. It has to be data driven. And finally, you should have been using resource efficient manufacturing, right?
Yeah.
If you come to, for me, this will provide chemical companies to not only just supply chemicals, but help hyperscale the data centers as well as the semiconductor conductor manufacturers to build a AI infrastructure which is not only a high performance one, but which is more energy efficient, which is more water resilient, and circular.
Sure. Let me also request Ambuj for his thoughts on the same question.
Yeah, so Assis, I think this is one of the most pertinent topic. Every day when we turn on newspaper, then we read about data center and the energy crisis. And you start with the talk that, okay, data is the new oil. So right now, so the today data centers is roughly around 80, 90 gigawatt, and it is going to be around 200 gigawatt odd by 2030, 31. AI data centers is again, like it's going to be more than 25% CAGR growth, touching our 120 gigawatt by end of this decade. And when in India, like today we have 1.5 gigawatt of data centers. A few years back, it was a very minuscule amount. And we are going to see somewhere around 6 to 8 gigawatt by end of this decade, thanks to data sovereignty and a lot of investments being done in India. So now, like in the hyperscale data centers, you have the high-end chips made of NVIDIA, like GPUs, CPUs of Intel and AMD, HBM of Micron, SK Hynix, and then your Samsung. These are being used, and these are very high heat emitting devices. And there was a Moore's law which told that, which prophesies that every year the number of transistors going to double. Every 2 years it's going to be double. Now for the AI chips, it is said that every 6 months the computing power is going to double. So that's the main challenge that's coming up, and the power is going to be the critical scaling factor. We read on, keep on hearing a lot of news coming, in the technologies. Someone is talking about deep sea data centers, then floating data centers, the power deployment, like nuclear power plants have been started to be open in US. Last week, if you hear the news, there was news came from SpaceX and Orbital, like they are going to launch some of the data centers, or like 8 gigawatt data center they're going to deploy in space. All these, like talks are going on. Now coming to the practical solution. Currently there is what data centers are coming up with. One is the high rack densities and the enabling the cooling technology, which Nitin was also mentioning. So here, there are different generations or different type of cooling technologies, because cooling consumes around 50% of the total energy consumption. And there you have, depending on the rack densities, like air cooling, water cooling up to 100 kilowatt, and then we are going for 200 kilowatt. Then we have direct to chip cooling or plate cooling. In the direct to chip or plate cooling also, we have single phase cooling and two phase cooling. So in the single phase cooling, or the two phase direct to chip, we have tubes which is going over the servers, and it is taking away the heat. Some places also we have ethylene glycol and water being used for the single phase. Now beyond 200 kilowatt, single phase direct to chip doesn't work. Then we need to go for a two phase direct to chip cooling or plate cooling. There you need lot of silicon oil or hydrocarbon or fluorine based chemicals. So that's also had a limitation, that it is going to be for 300 to 400 kilowatt. Beyond that, it's only the immersion cooling technology that appears to be the current solution. So in the immersion cooling technology, you have the entire high-end chips, which we were talking. So those are immersed in a tank, and this tank will have this fluid, this immersion fluid, high, non-conductive and dielectric fluid, which will take away the heat of this high-end chips. It will go to the top of the tank, condense, and then it will fall down. So this way the cycle will be established. So you imagine you are putting very high-end chips in a fluid, in a chemical. So that's, the advanced fluid, it's having the thermal properties more than 20 times of that of conventional fluids. And in terms of sustainability, some of the fluids which has been developed globally, they are able to reduce the power consumption by more than 60%. Reduce the footprint by 40%. There is no noise, there is no fans being used. The total cost of ownership is less than 60%. So, it's under technology adoption. Even as a part of Navin Fluorine, we do a lot of work on the data center fluid. We are partnered with one of the US customer doing the technology adoption, market adoption of the two-phase immersion cooling for the upcoming data centers. And there is also a lot of, as our own product, we do a lot of market development with companies globally to adopt this two-phase direct-to-chip cooling as well as immersion cooling. Even for India, when we talk to customers, they say that India could be an early adopter of this technology, because digitalization was also one of the area which India did very early adoption. Government is also very interested in it, and as we see that the data center industry is really growing very fast in India, so there is a humongous opportunity for Indian specialty companies to be in this space, because today the liquid cooling is around $500 million industry today. But it is going to be more than $3 billion industry in next 10 years. So that's the opportunity that it will bring. Today it is seen as very small, very less talks is talked about. But as we talk in this panel about the advanced materials, so this is really one of the area because of need of data centers, need of sustainability, need of eliminating water and huge power it's going to consume. So I hope, India could be an advantage.
Ambuj, on a lighter note, you're suggesting to the entire audience to buy shares of Navin Fluorine.
So you are seeing how the
Given
shares
the market
are growing.
potential that exists. But anyway, coming to my last question for this fantastic panel, to Dr. Yogendra and Ankur Singh, how can the Indian chemical companies minimize the environment footprint associated with manufacturing advanced materials to align with the global ESG mandates, given that we heard so many Japanese and Taiwanese and Korean companies looking at India now for some of this advanced material, and we will become part of their scope 2, scope 3 emissions, right? So what can we do to reduce our footprint to be sustainable for India and for the rest of the world?
Thank you very much. I think this is something very close to my heart and our Deepak company's heart, and therefore our tagline is with the Deepak logo, there is a responsible chemistry, right? So we talk about how we can be more responsible in terms of everything we do to manufacture, right? So manufacturing technology, 30 years ago, we have not heard about the zero discharge manufacturing facility in India. Now there are industrial zones where you are having a strict norms by particular pollution control board and the industrial development corporation that you can't discharge any liquid outside your factory, right? So like in a building, you have a platinum stars, right? Green building and all. So we have to actively work as a kind of a collaborative approach in a consortium approach so that we not make the mistakes what West has made the mistakes or China has made the mistakes in of polluting the land, soil and air and then done the development, right? So this is a great opportunity by implementing the innovations in sustainable technology from the beginning. So sustainability by design. So you actually have a mass balance building blocks from the petroleums to make your monomers or polymers or a metal, for example, or carbon or graphite and all, so that you have a less and less carbon footprint and better kind of a negative effect of during the life cycle of the material which you are actually bringing for this advanced sunrise industry. That's number one. Number two, as I said that we have to compel, you know that unless we are compelled to do something, we don't do it, right? So there are always incentives and there are always the regulations. So for example, now all devices which goes from China to Europe or US since last 20-25 years, and this is also I came to know when I was heading the marketing for electrical electronics, that if you want to export devices to Europe or US, you have to comply with a very stringent norms in terms of a recycle content and carbon footprint and all. Now all European companies are actually protesting. You must have seen on LinkedIn and all these big CEOs, they are saying that we are actually going on an extreme, right? Europe is going extreme in terms of carbon tax and all this part. Of course, some economies, they benefited from that, but European economy with a very high energy cost, they are bleeding. So we have to strike a balance. We can't over-engineer or overdo things. Of course, we want to create the industrialization and employment and all, but not at the cost of our cities are choking and we can't even breathe in Mumbai and Ahmedabad or in Delhi. So this is a bit of a philosophical, but it's doable. Right? So why don't we compel those all partners who would like to set up the factories in India and leverage Indian so-called cost-effective labor and so on, right? So the economy of scale is important, but we have to compel them that, okay, there is a cost to that. And you build the cost of environment management or having a development R&D focusing on those developing sustainable material, you need to build in this kind of your capex planning and also your proposal for joint ventures and all. This is exactly what China has done. China has actually compelled the foreign multinational to compulsorily collaborate with the university, setting up their R&D in China for sure as a exchange for giving them opportunity to operate in China and leveraging Chinese market. Right? So if the whole world is coming to India to leverage our market, right, and leverage our talent and workforce and hardworking Indians, why don't we also have to do that? Again, this is a bit of a policy matter. So it's a balance because we should not run away the all Japanese and Korean and Germans that, oh, this is too much of bureaucracy. Again, what we are facing in Europe now, you are starting this thing. So this is how we can do it, but consciously from all of us who are the professional in chemical and petrochemical industry, we can play our role to create the awareness in our own organizations, right, and in the manufacturing. And last but not least, can we use AI and machine learning to really improve the efficiency? So when you improve the efficiency, improve the OEE and the zero defect, zero effect kind of a program with the help of AI and machine learning, automatically your manufacturing process go to a more sustainable and resilient manufacturing process and you will be more competitive compared to the other competing economies. So this is my take on that. Thank you.
Thank you. Ankur, last words from you.
Yeah, no, I'll be quick. I think Dr. Chauhan has elaborated in a big way. See, if you look at any ESG demand or any scope 3 emission expectation, It's only three part. Customer expect us to produce cheap, produce clean, produce sustainable. That's it. And if you sum total all the regulation, nothing goes beyond these three. So let's start one by one. Produce cheap, especially in case of the material refining for the battery chemical. There is a lot of advancement on a continuous compared to the batch process. Element like plug flow reactors or continuous variable batch reactors have coming, which at a optimum cost can convert your sequential batch process into semi-continuous and continuous process. You save on your energy cost in a significant way. Second is your heat mass balance. There are a lot of technologies, especially around the heat pump. Europe is, because of the high energy cost, growing in a big way towards the heat pumps. Utilize that. You can also use hydrogen as an alternate material, which is available in abundance for your heating and energy purposes. It immediately helps you to get your ESG score quite well. And third is produce sustainable. Get rid of carbon materials if you can, and see how much you can green your value chain without incurring cost. You don't have to use extensive metal for the packaging area. Go on the high-end epoxies and polymers. I mean, if you look, I'll give you one example. If you look at the advanced material business we are in, we produce epichlorohydrin from glycerine, absolutely green. Caustic soda, salt is green. Power, we have renewables, so the upstream is sorted out. You produce epoxy, there is a lignin-based BPA. You add it, your epoxy is sorted out. You just have to add additives to make it high tensile epoxy-led packing material, which has just 5% of petrochemical residue. So there is a smart way to qualify for these three angles, and customer will love it. The last is taking responsibility of your product, which is life cycle management. Now, this is one area which is still under development, because if it is metal-based packaging, the life cycle management goes very significant. If it is new material, polymer-based packaging, then there is some ease. But this is where the cost is involved. So hopefully there has to be, the market has to become big enough to absorb that cost. Right now we are at nascent stage, so we won't be able to commit on that area.
So, Ashish, just to add on to both of their, so for me, where I was leaving, that sustainability actually has to be there from the inception. Yeah. So for me, just to take care, because doctor was mentioning about how we do it in our organization. So we start with the purpose statement itself. So in our case, in Clariant, we mention greater chemistry between people and planet. We have been part of the Dow Jones Index for over 2 decades. So for us, it actually starts, like we are part of the SBTI initiative, science-based. So you have to take targets. You mentioned about scope 1, scope 2, scope 3. So for us, it is very critical across all our sites. Scope 1, scope 2, we have taken, and we have already publicized our targets that we would be reducing by 2030, our scope 1 and scope 2 by 40%. Scope 3 emissions by 22%. And there are water reduction, waste reduction targets as well. For me, coming to India itself, because we very proudly are part of and want to contribute towards our PM's Viksit Mission 2047. Yeah. So we in the Clariant world have our first net zero site in India. Where doctor was mentioning, I inaugurated our first ZLD nearly 7 years back. And right now the power that we are using, our boilers run on briquettes. It's all solar powered. And I can proudly say that within the Clariant globe, we are the first ones to have a net zero site
That's
in
wonderful.
the country. Yeah.
So that's a great example, right, of Indian companies contributing to the global parents' footprint in a very positive way. So friends, I'm sure you'll all agree with me that you've had a wonderful primer on chemistry this morning. And I have to compliment ICN for scheduling this as the first session of day 2, because what a wonderful start to day 2 with such an erudite panel who could share so much on advanced chemistry. In the future of chemistry really looks bright in India if we start innovating more and work in a more sustainable manner, because that's the future. As we said, the 4 words, AI, data centers, EV, and EMS are here to stay, and therefore chemistry has a very bright future, not just for Navin Fluorine's stocks, but for everyone else. So thank you so much for this. I've noticed a lot of you all taking notes, which just expresses what I just mentioned.